today we're going to mainly see data analysis. In a way, we are going to use Python for solving some business problem, but today we'll focus more on understanding the data. Okay. So by now you're comfortable with pandas data frame. I'm hoping that you are comfortable with for loop, while loop, right? List, tuple, all those elementary concepts. So let's try to merge all those different concepts together to do some work which has got some meaning. Okay. Just simply learning the basics or elementary concept is not going to help us anywhere. So what we're going to do is, first of all, we have to do data analysis. So the very first thing I need to do is I need to import some data set, right? So we have a library called sklearn, scikit-learn, and that scikit-learn library is having some sample data set in it. Okay. So we're not going to download any data from anywhere. We'll just make use of it, and we'll do analysis of that data, right? So I'll give you a high level overview what we do when we get a data from client side or from from somewhere. How do we actually do analysis and interpret the data well? So first of all, let me import the data. So as I mentioned, that data is in sklearn, right? So sklearn is a package, dataset is a sub package, and from sklearn dataset I import load iris. Okay. So this is a very simple data set. So what this data set is going to have is, it will have information about flower, and the flower name is iris. So the person who has collected his data, he has collected information about this iris flower, and this iris flower can have three variety: virginica, setosa, and versicolor. So this data set you can use to solve for multiple kind of problem. I mean, rather I should say you can use this data set to understand multiple concepts of machine learning. With this data, you can do clustering. With this data, you can perform, clustering. You can perform. You can do classification also. Okay, but today we'll see.
How do we know we have to import load underscore iris only? I mean, we have to put underscore and all that.
Yeah, see, and any data which is available in this sklearn package, it will start with prefix load underscore. Now, since I'm importing data set with respect, which is about iris data set, that's why load underscore iris. But
okay, so whichever we want to import, we have to put load underscore. Then only we have to put anything we want.
Yep. Okay. But it's good to check what are the list of data set is available in this sub package. So in that case, you need to refer the documentation. This is the documentation of sklearn. Okay. So when I just simply checked within this sklearn data set sub package, what are the data set I'm having. So from there, I got to know that Boston data set is there, diabetes data set is there, iris data set is there, right? So out of this, I imported this iris data set. Okay.
Yeah.
Now let me import pandas. I'm going to import NumPy also. I'm going to import matplotlib also. And there's another library which I'm going to make you familiar is, and that is Seaborn. This is also another library for visualization. Okay, so so always start your code by importing all the necessary packages that you're going to use in your program. Okay. Now this is the data set I'm having, right? So first of all, I have to transform this data in tabular form, then only we'll be able to make sense out of it. So what I'm going to do is, first of all, this data set is available to us in form of class. So let us first instantiate this. So what I'm going to do is this, and let us see what this is. So you see here, there is a NumPy array which is having 4 columns, right? So each column is representing one feature about your plant. about your flower.
Okay.
And what are those features? So you'll see that this feature information is also given in this data part. So we have the data, we have the feature also, right? So here you see that the feature name is what? Sepal length, sepal width, petal length, and petal width. Okay, so these 4 features data we are having. So this is 4-dimensional data because we are having 4 number of columns. Okay, and this is the target feature. So target feature is means what? The attribute which we want to predict. So the target attribute is 0, 1, 2. So what 0 means? So 0 means it is setosa. If it is 1, that it means it's a versicolor, and if it is 2, it is a virginica. Okay, so these 3 are the varieties of iris data set. Okay, so I have to transform this data into well-structured pandas data frame. Okay, so I need to first of all slice different part from this data, right? So this is similar to dictionary. Okay, you see there is a key, there is a value, there's a key, there's a value. Okay, so if I have to transform it, first of all I need to use pd.dataframe because I want to create a pandas data frame, right? For I need to pass the data. So out of this, how I will extract this part, since this is a dictionary, right? So if I want to extract the value of this key, then what I need to do? I need to do here data, and then I need to pass its instead of, let me write this iris, it will not, otherwise it will be a confusion. Iris. Okay, what is the key of it? Data, right? This is data. Now let us see how this looks. Let me see the top 5 rows of my data frame. So you see these are the top 5 rows of the data frame. So these are the records corresponding to 4 attributes of iris dataset. But I don't know the header part, right? So now next thing I need to do is I need to bring the header, right? So again, if I have to check what are the keys of my this dictionary, I can write something like this, and it will give me the keys of this dictionary. So my feature name is in this key, right? So what I'll do is now I need to keep the header name also. So this data, and I need to have this, pass this key, then I'll get its value. Now let us see how does it looks. You see we have got the header also, right?
Like that we can give for rows also.
Rows automatically we got, right? When we pass data is equals to data and inside bracket data.
So here rows will get automatically, columns only we have to give the name.
Yeah, header name. So what this is doing, this data is equals to data underscore data, it is fetching you the data part. Now this column is equals to data underscore inside bracket feature name, it is giving you the header.
Yeah.
Okay, now there's only one thing missing now is the target variable. So these are called the predictors, features. Now I want a target. Target is the attribute which I want to predict. So target is the variety one, right? Which row is corresponding to Virginica, which row corresponding to Setosa, right? So I need another column which will have this information. So I am creating that column now. I'm naming it as species. Which species of is this attribute is species, right? And again, I need to call its appropriate key. So here you'll see that target. So target is a key where all of my species information is mentioned. You see here now species there. Okay.
Yeah.
Right. So this way we have prepared our data. This is called data ingestion. Okay.
Yeah, I just wanted to know that species names are there, no? Different names.
Yes.
So can we display the names?
Yes, we can.
That will come in the rules.
Yep. So right now we have just ingested data. The point which you are mentioning, it will come in the part of pre-processing of data. Okay. So till here, any doubt?
No.
Okay. Now let's come to the point which you just mentioned. Instead of having the 0 and 1, let us put the species name. Okay. So we know that 0 is for Setosa, 1 is for versicolor, and 2 is for Virginica. Okay. So we just need to replace this 0, 1, and 2 by their corresponding species name, right? So what I'm gonna do here, replace, right? And I want to replace 0 by what? Setosa. So this I have to pass as dictionary. 1 I have to replace by versicolor, and 2 I have to replace by Virginica. Right now you'll see that you see.
Yeah.
Okay. Now let's see how many number of records I'm having. What is the dimension of this data set? Okay. So ideally we should do just after importing this data set. So let me place it here. If I'll do iris.shape, it will give me the dimension of this data set. So it says that there are 150 number of records and there are 5 number of columns, right? We can also check how many number of records I'm having per species. Okay. So if I have to do that, what I can do is I have to use a group by function. Okay. So this group by, and I want to group by species because I want to check how many number of record I'm having per species. Right.
Okay.
And then count because I want to take the count. So you see there are 5 number of there are 50 number of records per species. Okay.
Yeah.
There are there's another thing we should check whenever we are getting this data, right? I mean, the first thing we need to do is we should check whether there's any missing value in this data or not. Sometimes the data which we get, it has a lot of noise. Sometimes the value is missing. So you can check your missing value by using is null and then sum. So what it will do is it will iterate over all the columns. It will check how many number of missing value I'm having in this particular column. So in this data set, there's no missing value. That's why you see in front of each header, there is 0. Okay.
Okay.
It's good to put comment for every syntax. Okay. Till here, any doubt?
No.
Okay. Now let us try to understand this data well. Okay. So that process of understanding your data is called EDA, exploratory data analysis. Okay. And there are 2 ways of EDA. One is called visual EDA and other is called descriptive EDA. Okay. So let's start with descriptive EDA and then we'll start visualizing some of the columns. Okay. So here I can put EDA. Right. Now, if I'll do describe, it will give me a 5-number summary. So what does it tell me? That total number of counts of record is 150. What is the mean sepal length? 5.84. What is a mean sepal width? 3.57. What is a mean petal length? 3.75, and so on. Right? Not so. This is not for sepal actually. It is yeah. This is for average, right? The average sepal length is this. The average sepal width is this. The average petal length is this, and average petal width is this. What is the standard deviations? What is the mean? 25 percentile, median value 75%, and maximum value.
Yeah.
Okay.
So whenever we write describe, only these things will be mentioned: count, mean, deviation, and minimum, maximum.
Yes.
Okay.
Yes. This is giving a descriptive information, right? This is called descriptive analysis. So what are the things that you can infer in a business sense from this syntax, from this result? So if you look at standard deviation, you'll see that the standard deviation is very high in case of petal length. So petal length has got maximum variability, whereas sepal width is having least variability, right? Likewise, there are n number of things you can
Yeah.
draw conclusions. You can check whether your this data is normally distributed or not. So you understand normal distribution, right? Gaussian distribution, a bell-shaped curve. So when do we see that the data is Gaussian distributed or normally distributed? When mean is equal to median, right? So here, what is my mean? Mean is 5.84 and median is 5.8. So more or less, we can say that this is Gaussian distributed, normally distributed. So if I'll plot the histogram, the sepal length, it will give me some bell-shaped curve. Right? And this bell-shaped curve is very, very important when we talk about machine learning or deep learning. Okay, because most of the algorithm, they have basic assumptions that the data which are feeding in is normally distributed. Okay, same goes on for this feature also. This is also normally distributed because your mean is approximately equal to median. Whereas if you look at this part, this is slightly skewed, right?
Yeah.
So again, when we say skew, there are two parts of skewness. One is called right skew, other is called left skew. You are aware of this concept, right? This is
So here it is right.
Here it is right. Yes, here it is right skewed. Why it is right skewed?
Because the mean value is more, right? No, sorry. This median is more than the mean value, right?
Yes.
The median 50 percentile is more than what is coming average mean, so it will be right side skewed, right?
Yes.
Am I correct or not?
I think they just think the opposite of this.
Okay.
Let me check. Even I am also a bit confused here. I can check the skewness. Okay. So we are talking about this feature, right? So I'll just do skew. So it is left skewed because the sign is minus, right? It is left skewed. So it is left skewed because your mean is smaller than your median. If you don't trust me, you can plot this graph also. You'll see that the tail will be elongated in left hand side, right? Are you convinced that this is left skewed?
Yeah.
Okay. Okay. If we'll talk about this column, can you tell me whether it's normally distributed or not?
Which one? Yeah.
This one.
Okay. Yeah, normal distributed.
How? It's
because mean is approximately nearby, right?
Yeah, it's nearby.
Can we take like that?
Yeah, I mean approximately it is normally distributed. Okay, but if we'll actually see it, it is slightly left skewed.
Okay, slightly left skewed, right?
Yes,
Okay.
slightly left skewed. Yeah, see. Okay. All right. Now let's do some plotting. Okay. Now let's do some visual EDA. Now we are interested in understanding how these features are related to each other. Okay. How these columns are related to each other. So for that, one thing is, since all the columns are numerical data, right? So we can go for scatter plot. So what I'll do is plt dot scatter. Let me first plot a relationship between this and this. So this and this and plt dot show. Wait, it will give me an error. I know. I forgot to mention the dataset name. See, this is the distribution of data, right? So if you so there are 2-3 things missing here. We do not know what is X label, what is Y label. So let us put the label also. plt dot X label will give me the X axis label. What is my X axis? What is my X and Y axis?
Sepal length is x-axis, you do.
Yes, sepal length is X axis. And what is my Y axis?
Width.
Yes. Now you will see that my figure is now somewhat.
No, we didn't write y label, no? We wrote both x only.
Oh, okay. Because I just copy pasted, that's fine. Right? I can put a grid box
Yeah.
also here. So what I'll do is I'll just do grid true. So you'll have grid in this plot now. Right?
Yeah.
So if you look, you know, it looks like there are some clusters in this figure, right? If you look here,
Yeah.
it looks like this is a one cluster, and maybe there's another cluster here, which is very much in line with our storyline also, because we know that there are 3 varieties of flower, right? Setosa, virginica, versicolor. So let us see whether these are actually clusters. Is there cluster available in our data or not? Okay.
Okay.
So
For different species, we can put different color also, right?
yes, for different species, we can put different color also. So instead of this sepal length and sepal petal, now let us see petal length and petal width relation, because we understood from sepal length and sepal width that there is some cluster. Let us see whether we see similar pattern with this 2 feature also. Okay. Yeah, it looks like there is a cluster, right? This is one cluster and this is another cluster.
Yeah.
Okay. Now let us try to add here another dimension. Right now this is a 2D graph, right? You'll see that in x-axis people and in y-axis people width. If I'll put another dimension of color, then this will become a 3D plot. It will be a 3D
Okay.
plot, but we have an intelligent way of depicting this 3D plot in 2D plane, and that uh, color information will be depicting whether that particular point is for setosa or versicolor or virginica, right? So what I'm gonna do now is C is equals to Okay. I think this is the best time to introduce you Seaborn library. So this plot we have created using Matplotlib, right? So later what happened is people built another library called Seaborn on top of Matplotlib. So personally, what I feel is it's much easier to use Seaborn compared to Matplotlib because
Okay.
you need to write much lesser number of code, but it comes with a cost. The amount of customization you'll have with Matplotlib library, you'll not find with Seaborn. So,
Okay.
but for this particular plot, I feel that I'll be able to convey my story better using Seaborn. And I also wanted to show you how to use Seaborn, right? So I'll create a similar plot using Seaborn. So I have imported Seaborn as SNS, right? And from the Seaborn package, I'm using scatter plot, and again I need to pass my x and y, right? And here you'll have plt dot show. Again I need to label my x and y axis. So I'll just do some copy paste here. Right, you see, using Seaborn also it is very much possible to do the same thing. Oh, great. Right, this is the same plot as this one. But now if I want to add a third dimension, which is the color, so I can add it like by using passing an argument as hue, right? So what I'll pass my species column into this as third dimension, and now you see, now this plot has become very valuable. I can
Yeah.
clearly say that there are 3 clusters, 1, 2, and 3, whereas the cluster, or I should say the variety setosa, is clearly separable from versicolor and virginica, but we see some overlap between versicolor and virginica. So it's slightly difficult to separate these two, but we can easily separate setosa from the rest of other variety.
Yeah.
Right. Till this point, any doubt, any confusion?
No, it's clear.
Okay, cool. Right. So this is scatter plot we have done. Now let me check whether my features are normally distributed or not. Okay. So for that, I will be plotting histogram of each of this feature, or I should first of all, let me show you the box plot. Okay. So box plot, you understand, right?
Yeah.
Okay. Let me know if you need some quick revisions, or you know. So
Okay,
again,
the last one. Yeah,
box
the
plot.
last one. Can we rewind? Yeah.
Yeah. So box plot. Okay. Let me first of all plot the box plot, and then I'll explain what kind of information the box plot is conveying. But you're clear with this, right? Scatter plot.
Yeah.
Okay. So I am now creating a box plot. The syntax is exactly similar. Now instead of using scatter plot, I'll be using box plot. Right? Rest all things will be similar. So you'll have some. Okay, here. X-axis, I need to put my species. And y-axis, I need to put petal length. Okay, so this is called box plot. So
Okay.
so what this information it is saying that it is first of all, this is a univariate graph. in my x-axis I'm having the species, and my y-axis I'm having simple. No, this should be.
So it will give different colors itself, right? We no need to mention.
Yeah, it will give different colors itself. And this is what this is my petal length. This box plot. Okay, so in my x-axis I'm having species, in my y-axis I'm having petal length. Okay, so you see what information it is conveying. Number one, it talks about the distribution of data. So if you see this middle line, every box is having one middle line between it, right? If that line is in perfectly middle, that means what? That means our data is normally distributed. Okay.
Okay. Okay.
If you will find this line slightly skewed at the top, right? Instead of center, if it is somewhere at top, not up at the center, then it is left skewed. If you find this line which is slightly below the middle point, then it is right skewed. Okay, this is one thing, one information that you can draw from box plot about the distribution of data.
So green one is a little bit left skewed, right?
Yes, yes. Even this is also slightly left skewed. We have
Slightly,
seen,
yeah.
we have seen also, right, by plotting this, by finding the skew. Yes.
Yeah.
The other information that you can draw is any point which is beyond this whisker. So this is a box, and these two are called whisker. Right? These are the whiskers. Any point which is beyond this whisker, those points are called outliers. Those are the extreme values. Okay. So the number two information that we are getting is my petal length is having one outlier for a particular species.
Yeah. For Setosa, we have two, right?
Yeah, for Setosa, we have two, one at the upper end, one at the lower end. Okay. Point number three.
Yeah.
The another thing you can draw from box plot is you can check. So from here also you can see that, right? In case of Setosa, the average petal length is smaller compared to versicolor compared to virginica. So you can do comparison also, species wise. We can say that in general, virginica is having larger petal length compared to versicolor and Setosa.
Yeah, yeah.
These informations you can insight you can draw from these kind of plot.
Okay.
Okay. Till this point, any doubt, any confusion?
No.
Okay. You want to see some more plots?
Yeah, one more we can see.
Okay. Because personally, I feel this job very interesting. I always like to create some beautiful plots, even though it's not required. Sometimes still I need to forcefully fit. So this is a thing which I can do for hours.
Yeah,
Okay.
by using box plot or like this scatter diagram, we can create some diagrams also, no? Write code and.
Yeah, we have written some code and created this graph. What exactly you are, meaning by this?
Like any gaming or something, if suppose we have to, draw some diagram, then also we can use scatter plot and box plot.
Yes, we can. You can create some interactive charts also. This is a static chart.
Okay.
Now you can style your figure also. So right now I feel this figure is looking very dull. Let me tell you some of the style component. So what I'm gonna do is I am using PLT style use, and I'm using ggplot. So ggplot is one style format, right? So if I'll rerun this one, you'll see that this plot visual will look different. The look and feel of this graph is changed slightly. Is this better now, or the earlier version was better?
Yeah, before one was better.
Okay. So
Okay, only color has changed, right? Background color.
yes,
That's it.
yes. So my personal favorite style is this
Okay.
uh, this one. Okay.
Yeah.
All right. Now let us plot histogram. Okay. So let us use again Seaborn SNS dot this not. So this plot is density plot, which is similar to histogram. So this is a histogram plot for petal length, right? So you see, majority of the flower they have petal length between 1 to 1.5 centimeter, right? Again,
Yeah.
again, I have to add a third component here, which is uh, color. So you see now for each of this species, I'm having one histogram. So again, here also you'll see that Virginica, the petal length is bigger compared to Setosa and versicolor, and this is in sync with our this graph. Petal length for Virginica is bigger than versicolor and Setosa. The x-axis
Yeah.
is the petal length, the y-axis is the count, number of records.
And whenever we have to plot histogram, we have to use this plot.
Yes. If you want to use CBOT, then this plot will give you histogram.
Okay.
Okay.
If matplotlib.
If you want to use matplotlib, then you have to use plt.hist. plt.hist, and then you have to pass your data. See, same thing. It has. We can plot using matplotlib. Okay. I feel the look and feel of a Seaborn plot is
Seaborn is good.
better than matplotlib.
Yeah.
That's why I prefer to use matplotlib. Okay. Any question? No, no.
No. No. No.
Okay. Now, what is the next thing that we're gonna do is, so we have understood well about the data part, right? We have drawn a lot of inference about the data. We have seen the distribution of data. We have done the bivariate analysis also, multivariate analysis also. Now let us find the correlation between different features. Okay. So for that, what I'm going to use. So correlation you understood, right? Pearson correlation, linear relationships, degree of linear
Yeah.
relationship.
Yeah. Yeah.
So
Hello.
yeah, am I audible?
Yeah. Yeah.
So this iris.corr, this will give you the correlation, right? So what it says that there is a good amount of correlation between your petal length and stipple length, right? You see the correlation here is 0.87, which is high correlation. Similarly, if you see the petal length and petal width, there is a huge correlation, which is 0.96, right? Means these two features are very much dependent on each other. In a business sense, what we can say that uh, the flower which will have bigger petal length is very likely to have bigger petal width, right? Which
Yeah.
is making sense also. It is saying similar to a person who is having bigger height will have more weight, right? So these two,
Why sepal length is not correlated? That is also correlated, no?
sepal
length.
length is correlated with sepal length, sepal width, and sepal length. Yeah, this one. Sepal width and sepal length is not correlated much. You see this? This is the correlation between sepal length and sepal width. Okay. So this is coming from the direct data itself. We cannot ask a question here why it is not correlating. This is how the data is.
No, I got confused because this rows and columns, both ways it is written sepal length and sepal width only, right?
Yeah. So if you want to understand the correlation between sepal length and sepal width, you have to see this figure, right? So this you see around the x-axis, and this sepal length, sepal width. This is the figure which is representing the relationship between sepal length and sepal width.
Okay, so we have to only correlate petal length, petal width, and sepal length, sepal width.
No, you can see the correlation between sepal length and petal width also. So you see here petal length, sepal width, petal length and petal width, which will be obviously one because you are correlating same thing with same column.
Okay. Yeah, understood.
Petal length and petal width, right?
Okay, yeah.
Okay. Sometimes so right now there are only 4 features. That's why you were very easily able to understand which features are correlated with each other, right? But if I'll give you 100 number of features, and if I'll ask you which 2 columns are correlated with each other, you will really have hard time to figure out which column is actually having correlation, right? So so we will be using another visual representation of correlation, and that is called heat map, right? So I will be using a heat map here. I'll pass this data frame, which is the data frame of correlation, and now the same information is represented to me in form of heat map, right? So wherever you see there is a light color, that means those features are highly correlated. But by just looking into it, we can see that this is light color, right? So petal length,
petal width are correlated. Yeah.
yes. Don't look at the diagonal, because diagonal is a relationship of sepal length with sepal width only. So obviously it will be having high correlation.
Okay.
Right. Okay. So this is the visual way of inferring the same information.
Yeah.
Okay. Now this is a very high level way of understanding our data. So these are the must have thing you should know whenever you are doing the data analysis. Okay. I'm wondering whether I should start the next topic today, or maybe we should start tomorrow.
What topic you're going to start?
So the next thing
you can start tomorrow.
Yeah. So the next thing which I was thinking is, maybe in the next class I can actually create our machine learning model and show you classification problem.
Yeah.
Right.
Yeah.
So in the next class, we will be we will be building a classifier, and we will be coming up with one model that will classify your input data as one of these three variety of flour.
Yeah.
Okay.
Yeah.
All right. Let me stop this